Welcome to Tep Talks. This time around we are going to go on with how to get the gradient of the line. So you're looking at the gradient, and another term for gradient is slope between the points. Then you can say, consider the line AB with A x1, y1 and B x2, y2 are shown below. So if you have this line, very straight line, and you have got the coordinate A as x1, y1, this is coordinate B as x2, y2. So the slope must be at an angle of 90 degrees. This is our slope stroke gradient. So another name for slope is gradient. Somebody may ask me, where are gradients being used? They are being used by engineers, especially when they are doing the construction in the roofing. So the roof is always set at this angle of 90 degrees from up to the ground. So they make use of these gradients. So I've said that is the, so you can say the gradient of the line AB is given by the formula which we call gradient M, which is equal to change in y coordinate all over change in x coordinate. So what is it? We are getting gradient M. Gradient M equals, when you change in y, you can either say y1 minus y2 all over x1 minus x2, or M equals y2 minus y1 all over x2 minus x1. All these are formula for the gradient which you are going to be using. So when they say how do we get a gradient, simply look at change in y coordinate over change in x coordinate. As you're going to look at examples, you can say find the gradient between the following points. Between the following points, you can say part A 2, 1 and 5, 5, part B -2, 4 and 6, 9, part C 2, 4 and 5, 7, part D -3, 5 and 4, 10. So we are going to look at the solutions. To those questions. So they have said we find a gradient between the following points. So another term for gradient is slope. So the first part is find a gradient between 2, 1 and 5, 5. So we are looking at the solution for part 1 is 2, 1 and 5, 5. So what we're going to do is this. You have got two coordinates, you can baptize them. This is x1, y1. This is x2, y2. So how do we get the gradient m? Gradient m is the same as y2 minus y1. Even if you start with y1, you still have no problem. All over x2 minus x1. So never say change in x over change in x. We start with change in y over change in x. So what is y2? Is already 5 minus 1 all over 5 minus 2. So what are we getting? We are getting a 4 out of 3. This is the gradient for first part. Let's go to part B. Part B is saying between negative 2, 4 and 6, 9. So this is x1, y1, x2, y2. So we are going to say gradient m equals, you can even say y1 minus y2 over x2, x1 minus x2. So what is y1? Y1 is already 4 minus 9 all over x1 is negative 2 minus 6. So we are getting negative 5 out of negative 8. So the negative and negative crosses, so we are coming with 5 out of 8, which is the gradient m. So we are going to part C. We are going to part C. We are moving part C, which is having 2, 4 and 5, 7. Still this is x1, y1, x2, y2. We say gradient m equals y1 minus y2 all over x1 minus x2. What is y1? Y1 is 2 minus 5 all over 4 minus 7, which becomes negative 3 out of negative 3, which is giving us a 1. So I've already got the slope between that as that. So we are also moving on to part D. We want to go to part D, which is having negative 3, 5 and 4, 10. Can look at those points. There are two coordinates which we need now to baptize them. This is x1, y1. This is x2, y2. We say gradient m equals, can say y1, because we said gradient is changing y over changing x, over y2 minus y2 all over x1 minus x2. So long as it is change, you follow that. So what is y1? Is negative 3 minus 4 all over 5 minus 10, which is negative 7 out of negative 5, which is 7 out of 5. So this is what you can do as far as getting those solutions about the gradient are concerned.